All right, today we are going to review long division using this standard algorithm. So this is something that you guys have already, oh, I forgot that I have to mirror it to the board. Sorry, hang on one second. All right, so we're reviewing long division using our standard algorithm. Now, some of you have learned some really creative phrases to help you remember the steps of long division, like does McDonald's sell cheeseburger? Okay. I've always done dad, mom, sister, brother, and then it just kind of depends on who you learned it from and what they used. Okay, so today we're doing the dad, mom, sister, brother. You need to know. We're going to talk about that in a little bit. Okay, we're going to talk about that in just a little bit. So the first D is divide. So we're going to fill in the blank. We need to know that in our acronym here, the D means divide. M, we have to multiply next. So why do we spend so much time multiplying beforehand? Because we have to be able to multiply in order to divide. Then we subtract. Yep, bring down. Bring down. Okay. So over here, where we have the steps, we have the D, which is divide, and we are going to think of dad. Mom is next, representing multiply. We can either put sis or sister, which is subtract. B for brother, which represents bring.
Can you do bro for brother?
Sure. And then D is our dog. Dad, mom, sister, brother, dog, which is for bring down. The R, when we get to long division, it's not always done when we get to bring down because we have to repeat the steps. So our dog, Rover, is for repeat. Okay, so we're going to use these steps to solve the problem that you see right there, 3,258 divided by 6. Can you make a group of 6 with 3?
No.
No, that's not possible. We cannot make a group of 6 with only 3, okay? So we have to use what we call 0 the hero to hold the place. So we put a 0 up here. Now, can we make a group of 6 with 32? Yes, if I have 32 circles, okay, I could then make a group of 6. So yes, I can. How many groups? 5. So I'm going to put a 5 up here. Now, my next step is to multiply 6 times 5, which is 30. So that is what I'm going to write underneath the 32. It's a little crooked, sorry. I'm having a hard time getting it straight. There we go. Okay. Now I've got sister. I've done dad, mom. I've got sister, which means subtract. So I'm going to subtract 32 minus 30, which is 2. Then brother and dog represents bring down. So what am I bringing down? This 5. I'm bringing down the 5. And I have to repeat all of those steps. So notice I have this little box right here that says repeat steps. How many groups of 6 and 25 now? 4. So I'm going to put a 4 right up. Oh, I can't reach it on my screen. Right up here. And then the multiplication part, 6 times 4 is 24. So I'm going to put that here. Sister tells me I need to subtract. So 25 minus 24 is 1. And brother and dog tell me to bring down what? The 8. Okay, do I need to repeat again with Rover?
Yes.
Sure do. Okay, how many groups of 6 are in 18? 3. So I need to put that up here at the top. What is 6 times 3? 18. Okay. And then sister tells me to subtract 18 minus 18, which is 0. Do I have anything else to bring down? Nope. I have nothing left over. 0 is what I ended at, so I am completely done. Let's look at our practice. We are going to use cubes every time we problem solve. You also have your little cheat sheet at the back of your journal with keywords so that it can help us to figure out what we need to box, because we will always box our keywords. Remember that cheat sheet is on the front side of the page that has your math talk and your cubes. We glued that whole problem solving keywords page with addition, subtraction, multiplication, and division on the front side of our cubes and math talks page. So you can use that if you need it. All right, there are 330 baseball players. I'm going to circle 330. Evenly divided, that's a keyword I want to make sure I box, on 22 teams. Underline my question. How many baseball players are on each team? This is what your problem should look like. Anytime you have a word problem, it should be marked just like this. Numbers are circled, keywords are boxed, question is underlined. If it's super, super long, sometimes there's extra information that you want to eliminate. Okay? Here we don't have anything extra. All right, so now we're going to take our problem. I'm going to solve it by dividing what?
330.
Very good. So we want to set it up. I want to point out real quick that if I were to write a division problem, it could also look like this. What does that look like? Looks like a fraction. A fraction is a division problem. It's the top number divided by the bottom number. So if you see it set up like this, know that you're still dividing. You have to set it up this way in order to actually solve it. But if you see it given to you like this, it really just means 330 divided by 22. Okay, can 22 go into 3 at all?
No.
Nope, so 0 the hero is going to hold my place. How many groups of 22 can be made from 33?
1.
Only 1. Okay, we multiply now because Mom tells me to multiply. 22 times 1 is 22. Sister tells me to subtract.
11.
Brother and dog mean bring down. And then Rover says repeat. Now, can 22 go into 110?
Yes.
Ooh, how many times?
5.
5?
6. Exactly. 5 exactly.
5 exactly? Let's see. Mom tells me to multiply, so let's test it out. And it is exactly 5 times. So we've multiplied it. And sister tells me to subtract. I have nothing left to bring down, so I'm done. And my answer is 15 players, which is Z. Okay. Number 2. Last Friday, 2,730 students rode the bus to school. Each bus carried exactly 42 students. How many buses did the school district use?
7.
Okay, so 2,730 students. Each bus carried 42. How many buses did we use?
No idea.
Okay, I want you to also think about anytime I have a really large number, that's like my total number. 2,730 is my total number of students. So I have a total and I have part. I know that a bus can carry 42 students, but I want to now know how many buses I need. So I'm going to group groups of 42 students on each of those buses. So anytime you're given a total, you're basically working backwards. So you're dividing to figure out that missing piece. So I'm going to take 2,730. I'm going to divide it by 42. Now, can 42 go into 2?
No.
Placeholder 0. Can it go into 27?
No.
Another 0 the hero there. So how many groups of 42 can be made from 273?
No idea.
How could we figure that out?
Divide. Multiply.
Okay, I'm going to try something. This might backfire on me in a minute here. Okay, what I like to do is I like to look at the first part of a number. So I'm just looking at the 4, and then I'm looking at the 27 of 273. So the 4 and the 27. How many times can 4 go into 27? 6 times. So let's try 42 times 6 and see if it gives me a number close to 273. So 42 times 6, 12. That's 252. Will that work?
No. Yes.
Okay, so if you say yes, why does it work?
Because it's 273. It's close.
It's close, but it doesn't go over. If it went over, I know it would be too much, so we would have to bump it down a little bit. So yes, it does go in 6 times. We're going to subtract 252 because sister tells me so. So once I subtract, I'm left with 21. But brother, bring down. So remember my trick. If I'm not sure how many times 42 can go into 210, just look at the beginning of each of the numbers. 4 goes into 21, how many times?
5.
5 times. So let's try 42 times 5. And what do we find?
210.
It is 210. Sister says subtract. I have nothing left to bring down. So we know that my answer is B, 65. There is another method you can use, and maybe some of you, when you're not sure, you just always start at 5 because 5's right in the middle, and you say, well, I'm not really sure how many times 42 goes into 273, so when you're here, you just say, well, I'm just going to start at 5. Then I know if I need to go up or down. Okay? Does anybody use that method where you start in the middle? It's like a benchmark kind of.
I start at 50.
You do 42 times 5. If that's your method, it works great. But sometimes you do a little bit more work than you need to. The method I'm showing you here where you just are looking at the beginning of your numbers helps you get a little bit closer to an accurate number. Okay, so let's do the next problem together. Let me move my little box out of the way. Okay, Kinsley has an expansive seashell collection. She has been collecting shells, you're good, for 8 years. Anything that I need to mark in that first part of the problem? Jeremy, tell me what I need to do.
Nothing.
Nope. I need to do something. Jeremy, do you see it?
You eliminate it?
Nope. Do I eliminate it? I don't know yet.
No.
What do I see?
Circle 483.
In the first sentence?
Got there yet. No.
8. It's in written form, but it's still a number. Oh, it is a second sentence. The first part of the problem. You're exactly right. It is the second sentence, but it's the first part of the problem. Numbers sometimes show up in written form. Don't overlook them. Sometimes it's important information. We'll find out in just a minute if we actually need it. If we don't, we'll mark it out. Okay, so we know Kinsley has been collecting shells for 8 years. She separates is the key word because we're taking it apart. She separates the 483 shells evenly into velvet-lined boxes. Go away. I'm sorry. Each box holds 23 shells. How many velvet-lined boxes does Kinsley use? So do we have any extra information that we do not need? Elise.
Velvet-lined boxes.
Definitely don't really care about velvet-lined boxes that much. It's just a detail that we don't really need to know. Jude?
The 8 years.
The 8 years. We don't need to know that she's been collecting for 8 years. It asks us nothing about that, so we're going to eliminate it. It's also not necessary to know velvet-lined boxes. That's just a little detail. Velvet-lined. We could just say how many boxes. Okay, Bowen. Yep, don't really need to know that. So we have now marked out all of the information that we no longer need. We've marked the information we do need so that it stands out to us. Okay? All right. So what am I going to have to do now to figure out my answer? Natalie.
483 divided by...
Very good. How many groups of 23 can be made from 4?
0.
0. The hero tells me so. Okay? How many groups of 23 can be made from 48? 2. 23 times 2, Mama said
46.
46. Sister says subtract. Brother says bring down. How many times can 23 go into 23?
1.
Mama says multiply. 23 times 1. Sister says subtract. I have nothing left to bring down, so my answer is 21. Okay. Today you guys are going to have a practice page. Ooh, we're almost out of time. So I'm going to go ahead and just give you that to start on right now. Whatever you don't finish will be homework.